In this video, we'll be talking about the half-adder circuit. Before you go through this video, please ensure that you go through the basics of addition of binary numbers. Let's move on to this video.
Half-adder. I'm going to divide this video into 4 sections. Number 1, aim of this video, and number 2, theory behind half-adder circuit, what is half-adder, what is the use of half-adder, and number 3, how to design the half-adder circuit using various gates, and number 4, we'll be talking about how to implement the designed half-adder using logic gate simulator. The aim is to design and implement half-adder using logic gate simulator, and here we are going to have 3 tasks. Number 1, design the half-adder using NOT, and OR gate, basically using sum of product form, and second task is using the compound gate, the XOR, and the basic gate AND gate. And number 3, using NAND gates alone. Basically, the half-adder circuit is a combinational logic circuit which has no memory and whose output at any instant in time depends only on the combination of its inputs. It is used for the purpose of adding 2 single bit numbers. You see, this is a half-adder and it contains 2 binary inputs and 2 binary outputs. So basically we call the outputs as sum and carry. So as you see here, we are having 2 inputs and 2 outputs. Let me call the input variables as A, B, and the output variables be S, that is sum, and C, the carry. Now let's start designing the half-adder. Step 1, identify the input and output variables. So as we said, the input variables are A and B. It can be either 0 or 1, and the output variables are S, the sum, and C, the carry. Step 2, draw the truth table. So I have my inputs A and B and my outputs S and C. If I pass 0, 0, my output, the sum would be 0 and my carry would be 0, right? So basically you know the understanding of how to add the binary numbers, right? Okay. So if I pass 0, 1, my sum would be 1 and my carry would be 0. And if I pass the inputs as 1 and 0, again the sum would be 1 and carry would be 0. Then if my both the inputs are 1, then my sum would be 0 and I would be having a carry, right? So this is the truth table. And step 3, we are going to make use of the truth table and draw the corner maps, right? That is K map using the truth table, and we are going to determine the simplified Boolean expressions. Okay, let's see. So now I want to draw the K maps. Okay, so first I am going to draw the K map for the output sum. Okay, so this is my map. So I have AB, then A bar, B bar, then A and B. Okay, so based on the truth table, what will happen if I have 0, 0, right? So I have the sum 0 then 0, 1 I have 1. Then for 1, 0 I have the sum 1. Then 1, 1 I have the sum 0. Right? So now I have drawn the map for the output sum. Now let's for carry. For 0, 0 I would be having 0. For 0, 1, 0. Then 1, 0 I have 0 and 1, 1 I have 1. Okay. So now that I finished drawing the K maps, now I have to determine the Boolean expressions. Okay. So how do I do? I will just encircle the ones. So here I have 2 and here I have the 1. Right. So now I am going to write the expression. Okay. So for sum, if I want to write, what is that? Would be using sum of product form. Okay. So this is our task 1, right? Using sum of product form, we are going to write the Boolean function. Then subsequently we will draw the logic diagram for it. So if I take the sum of product form, my sum S is equal to A bar B plus. So you look at the encircle one, A bar B plus A B bar. So that is my sum. And if I take the carry, I have only one. So that is A dot B. Right? Okay. Then if I use the compound gate XOR and AND gate, so I would be simplifying my Boolean expression as A XOR B, that is for sum, and carry remains the same. C is equal to AB. Now step 4 is to draw the logic diagram. So here we have the expression using sum of product as well as using the compound gate XOR, right? So now let's see the logic diagram for the sum of product form. Okay, so what is the expression? S is equal to A bar B plus A B bar and C is equal to A dot B. Okay, so now I need the NOT gate for making the inverter and the multiplication of binary numbers, that is I will be using AND. Then I have this addition where I will be using OR gate. Okay, so this is my logic diagram for the sum of product expression, right? So A that I am taking here, then I am just multiplying with B bar, right? So I am using the NOT gate. So I here, what are the inputs? A and B bar, and similarly here I will be having A bar and B. Then finally I will just give it to the OR gate. So I will get the sum. S is equal to A bar B. Here I will get A bar B, and here I will get A B bar. So finally I will get the sum. Then what is the carry? What I have to do with the carry? I will just take the inputs and I will just do the multiplication, right? So with the AND gate. So I will get C is equal to A into B. Next, we are going to draw the logic diagram using XOR gate. So what is S? S is equal to A XOR with B and C is equal to AB, right? So now it's very simple. I will be using the XOR gate and I will pass the inputs A and B, and I will pass the same input to the AND gate where I will get the output S is equal to A XOR B and C is equal to AB, right? The design is very simple. Now we are going to implement the design half adder circuit using logic gate simulator. This logic gate simulator is an open source tool where you can experiment with and learn about the logic gate in building combinational and sequential circuit. So let's go to the logic gate simulator. If you go to this site, you can download the logic gate simulator. Now I have in my system where I'm just going to open the application. So when you open the logic gate simulator, you will get this window where you have all the components here. If you see here, basic gates, then you have the compound gates, then you have the input, output, then all your clock. So I am going to build the half adder circuit using sum of product form, right? Where the expression we have seen S is equal to A bar B plus A B bar. We are going to use NOT gate, AND gate and OR gate. Okay, let us pick the gates, right? So we need how many AND gate? We need 3, right? So I will just take this and I will just put Control C, Control V, Control C, Control V, right? Okay. So I will just make it align. Okay. So then I will be requiring the NOT gate, right? So I will be taking this NOT gate for inverting my inputs, right? So how many NOT gate that you require? You need 2, right? So I will just do Control C, Control V, right? So I will just keep it here. Okay, so I will just keep it here. Okay, then what else you require? You need the OR gate, right? So we have taken all the gates that are required to build the half adder using sum of product form. So now we need to pass the input, right? So how do you pass? You have to take the input gate, right? So this is my input. So I will be taking how many inputs that we have in half adder? You have 2, right? So I will just take, then I will just give Control C, Control V. Okay. So these are my inputs. So what are the variables that we call? A and B. So what I will do? I will just right click here and I will rename it as A. Okay. And then the next input I will just again right click, rename and I give the variable B. Okay. Then we need 2 output, right? So we need 2 output terminals, right? Where I will be taking one for sum, then I will just do Control C, Control V, right? Another one is for carry. Okay, so I will just again do rename and I'll call this as S and this as C, right? So all that what we have done, we have taken the input terminal and we have the output. Then I have taken all the necessary gates, right? So what else is pending? We need to wire it, right? So you can just click over here and give to the start from the source and end to the destination. Okay. So what is this? This is A bar. So what would be the output of this? This I am just taking this as A bar, A bar, okay, A bar, B, right? I will just give here A bar, B. Then for this I'll be taking B bar, B bar, A, right? B bar, A. Okay. Then, so I have to add these two, right? So this is A bar B and this one is A B bar, right? So what is this? this is nothing but my output, the sum. Then for carry, you know the expression, C is equal to A dot B, right? So I need to just take A, okay, just click and drag the wire to the next terminal, okay. Then again click, then drag and give it to the AND gate. So what is the output here? This is nothing but A dot B. So that I will connect it to the output terminal, right? So you would have seen here, there is a flow here. This indicates the output is on, right? Which means since this is an inverter, I am not passing any input, but I am receiving the output, right? If you pass 0, you will get 1. If you pass 1, you will get nothing, right? So let me verify my logic gate according to the truth table what we have. Okay, so 0 0, I will be getting sum as 0 and carry as 0, and 0 1, I will be getting the sum and I will not be getting the carry, right? This red indicates that the output is on, right, or the input is on, right? Next, I'll just make 1 0. I'll be having 1 0. I'll be having sum high and carry the low, right? And if I pass the input to both A and B, then I will be having sum 0 and carry 1, right? So this is one way in verifying the truth table with the logic gate simulator. Suppose if I want to observe this in a graphical waveform, right? So what you have to do is, so I will just start from 0 0. So what you have to do is, you have to click this icon, show logic analyzer, right? If I click over here, you will get this window, right? You will get this window, right? If you see here, I am not passing any input. My input is 0, output is also 0, and I will just make it bigger so that so both are your inputs A and B, and your outputs are S and C, right? If you see here, I am not passing any input to A as well as the B, and I am receiving S is equal to 0, C is equal to 0. Okay, let me go and change this. I am just giving 0 1, right? I am just making B high. Okay, now if you go and look into the waveform oscilloscope, so you will see my A is 0 but B is 1, but what happens to the output? Sum becomes high, right, and C become 0, right? So again, if I change this to 1 0, A becomes high. You see here, A becomes high and B is 0, and you get the sum high, right? This is the transition period where you get A is 0 and B is also 0, right? So that's why you get this pulse over here. And again, if I am going to make the inputs are 1, right, then I will get sum 0, carry 1. You see here, I am just making both the inputs are high. I get here sum 0 and carry 1, right? So this is to view your state of the output with respect to the input in the oscilloscope, right? So let me go to this simulator. Okay, so this is how it is. This is your circuit. Okay, so I build with the input terminals and output terminals from the components available in the left panel, and you can change your input and observe what is the change that you get in the output. And as I said, this flow indicates that output is on, right? If you can see here, right? So where are the flow, right? In which direction it is flowing, and this is how you get the corresponding output. Suppose, say for example, I don't want this wire. By mistake, I have connected this, right? Instead of connecting from here, by mistake I connected this. Okay. So how to delete this? I will go here, show or hide the false condition, right? So I will just go and click over here, right? Okay, so then I'll just reconnect. Then now that I have built the half adder circuit using sum of product form, I want to retain this circuit for some reason, right? You understand what I mean? I want to retain this circuit for some reason. I'll be using the same circuit for my next circuit. So here you have the fantastic option. You can create all the components whatever you have designed here as a single IC, right? So you see here when I go create IC, here you can see all the elements are put it into an IC, right? If I click over here, right, I will get the change in the user gate, right? This is my gate or IC that I have prepared. Okay, so I will just rename into half adder circuit 1, right? I am just giving the label half adder circuit 1. This is your IC, right? Suppose if I want to use the same IC, what I'll do, I will just go for some other application. If you want to use the same IC, what you will do, I will just go and take the new, right? I will just go and take the new. Before, if you want to save, you can save this as, for example, I am just giving this is half adder 1. Okay, so I will just save this. Then I'll be having the new. If you want to make use of the IC what you have made, then what I'll do, I have to go and open the IC what you have made, right? So I will just click over here and I will get whatever IC that I have made here. Okay, see, for example, here is an IC made with the help of compound gate, right? XR and AND gate, right? So here I am just giving A to one terminal and B to another terminal, where I will get S is equal to A XOR B and C is the product of the two inputs, right? Using AND gate, I will get AB, right? So I can verify this same with 1 0, the sum is 1, then 1 1, sum is 0, carry is 1, then 0 1, again sum is 1 and carry is 0, right? So I can make use of this as an IC by clicking create IC for my future applications. Okay, so this is how you implement the half adder circuit in the logic gate simulator. Okay, if you want to make a copy of this image, you can go to this save circuit as image, right? So I am just going to click over here. I can name this as half adder. Okay, so again I can go and check whether that image is placed in the respective circuit what I have, right? This is for the documentation. If you want to make the report of the experiment what you have performed, you can always do copy the circuit whatever design and save as image. Then you just have to copy that image into your Word document, right? I believe you understand how to pick the component, how to pick the input terminal and the output terminal, and how to do the wiring, and how to visualize your output by giving your inputs, and also in a graphical form using the oscilloscope, and you know how to create the designed circuit, an IC, how to make use of that IC for your future application. That will see when we go to the higher applications. Then you know how to save the circuit as image. Then once it is done, you can very well go and save the file. Okay, so this is the logic gate simulator, and this is how you implement the half adder circuit. And coming to the practice exercise, as this would be considered as the task 3. So we have already completed the design and implementation of half adder using NOT and OR gate, and using the compound gate XR, and then AND gate. And this is going to be the task 3 for you to design and implement the half adder circuit using NAND gates alone, and verify your result using logic gate simulator. Practice this, and let's see in the next video. Next one is we should understand the limitation of the half adder, right? So we have in our adder circuit, we have a half adder as well as a full adder, right? What is the disadvantage that we have in the half adder, right? As you see in the circuit diagram, we have 2 inputs and we have 2 outputs, right? There is no point in discussing about how to add the carry bit from the previous addition operation, right? So no scope of adding the carry bit resulting from the addition of previous bits. This is considered as a major drawback of half adder, because in real life scenario, if you take you need addition of multiple number of bits which cannot be accomplished using half adder circuit. So how to overcome this drawback? Obviously we have to go for the full adder circuit. I hope this video would be useful to you. Let me leave this video here, and see you in the next video. Thank you.